This is lesson 3.5b. We're going to continue evaluating algebraic expressions. So we're going to be plugging in a value for the variable. This time we're going to be working more with decimals and fractions. So open up your notebook to the next blank page. Write 3.5b on the top, and let's look at example 3 here. So example 3 says, Mr. Grant wants to tile a 27 square foot area with square tiles. Let S equal the side length in feet of a square tile. Use the expression 27 divided by S squared to find the number of tiles Mr. Grant needs to buy. So pretty much what they're telling us is that he wants to tile a room, and the area, which is the space inside, is 27 square feet. We have to figure out how many tiles he's going to have to buy, and we're letting S equal the side length in feet. So let's start by rewriting this expression. 27 divided by S squared. And that makes sense because to find the area of a room, we would do S times S. So they're saying S times S is going to equal that 27. So now we're just reversing it. We're going to say, okay, well, 27 divided by that S squared is going to tell us how many tiles we'll need. So that's how they develop that expression there. 27 divided by S squared. Let's see, what is S going to equal? S is going to equal 1/3 of a foot. So S is going to equal 1/3. So they told us what S equals. We are now going to plug that value in. We no longer want the S there. We want it to say 1/3. So if we're evaluating an algebraic expression and they give us a value, we no longer want that variable there. We only want the value. So notice how I put that fraction in parentheses because we're going to have to square the whole fraction. So we have 27 divided by 1/3 squared. Okay, order of operations. Let's follow PEMDAS. First step, parentheses. Okay, the only thing in those parentheses are the fractions. Second step, exponents. Ooh, we have an exponent. So off to the side, we have to do 1/3 squared. Well, what does 1/3 squared mean? 1/3 squared means that we are going to do 1/3 times 1/3. Okay, so off to the side, let's do that. 1/3 times 1/3, what do you get? Numerator times numerator, 1, denominator times denominator, 9. So 1/3 squared is 1/9. Bring down the rest. 27 divided by 1/9. Okay, so we have 27 divided by 1/9. Now I see some division with a fraction. We need to make everything a fraction. And now we have to remember those 3 letters from when we're dividing fractions. Keep, change, flip. 27 over 1. Change that division sign to a multiplication sign. Flip 1 over 9 becomes 9 over 1. Now we have a multiplying fractions question. So we have 27 over 1 times 9 over 1, which is pretty much like we're saying 27 times 9. What do you get? I got 243 tiles. So that means that Mr. Grant would need 243 tiles that each have a side length of 1/3 of a foot. Let's look at this try it question. Suppose Mr. Grant decides to buy square tiles that have side lengths of 3/4 a foot. How many of these tiles will he need to buy? Okay, so now we're letting S equal 3/4 a foot. We're using that same expression. So again, copy the expression into your notebook. 27 divided by S squared. And now S equals 3/4. Okay, so they're telling us what S equals. Let's plug it in. We'll have 27 divided by, I'm using this information, S equals 3/4. So let's plug it in. 3/4 squared. So that algebraic expression stays exactly the same. Now we're just getting rid of the variable and plugging in the value they gave us. Everything else comes down. 27 came down. The division sign came down. We plugged in the value for the variable. The exponent stays there. Okay, now we're going to solve this expression using the order of operations. So first step, parentheses, nothing. Second step, exponents. Yes. 3/4 squared means we're going to have to do 3/4 times 3/4. And what do you get? 3/4 times 3/4, you get 9/16. And that's in simplest form. So 3/4 squared is 9/16. Bring the rest down. 27 divided by 9/16. Make everything a fraction. Next step, let's do our keep, change, flip. Keep, change, flip. 27 over 1 stays the same. Change division sign to multiplication. Flips. 9 over 16 becomes 16 over 9. Now you should be doing your that multiplying work off to the side so that you don't have to erase it like I just had to do. Now let's see, can we simplify before multiplying here? We should always look. We look on the diagonal. 1 and 16, nothing to simplify there. We have a 1. 27 and 9, is there a number that goes into both 27 and 9? If yes, what is it? 9 goes into both 27 and 9. So I can divide 27 by 9 is 3. 9 divided by 9 is 1. Now I multiply straight across. 3 times 16 is 48 over 1. So he would need 48 tiles. So I hope you notice that the pattern is get the expression, plug it in, plug in the value for the variable, and then you're following PEMDAS to evaluate the expression. Okay, so now I want us to just look at an example with a table. So here for 27, it says evaluate the, for 25, we're looking at 25, evaluate the expression for the values of j. So they gave us this expression, 2j plus 3/5. They gave us 3 different values for j. So this is telling us that j equals 1/2. J could equal 4/5. J equals 1 3/4. Remember that j can equal any number, whether it's a fraction, a decimal, a whole number. So we're going to follow the same steps. Let's rewrite the expression. The initial expression they gave us, 2j plus 3/5 when j equals 1/2. So let's plug this in. Anywhere you see a j, you're going to write 1/2. 2. Oh, I'm plugging in j. There's a number there. I don't want it to say 2 and 1/2. I want it to say 2 times 1/2 because I have a variable and a coefficient, and that means multiplication. So we have 2 times 1/2 plus 3/5. Bring everything else down. So we have to follow PEMDAS here. So our first step, parentheses, nothing. Second step, exponents, nothing. Third step, multiplication or division. Yep. So off to the side, 2/1 times 1/2. Oh, I can simplify before multiplying here. 2 and 2 can both be divided by 2. 1/1. So 2 times 1/2 is 1. So now I have 1 plus 3/5. Well, 1 plus 3/5 is 1 3/5. Okay? But also remember that when you add and subtract fractions, if that wasn't a simple addition there for us to say, we would line it up vertically. 1 plus 3/5. Well, over here we have no fraction, we have 0/5. So we would have 3/5 and 1. So when j equals 1/2, and we evaluated the expression, we got 1 3/5. Okay, the last question, I want you to evaluate the expression 2j plus 3/5 when j equals 4/5. So take that 4/5, plug it in, and let's see what's your final answer. So you plug it in and you should get 2 times 4/5 plus 3/5. Now I'm going to follow the order of operation. 2 times 4/5, cross it off. I got 8/5. I'm going to leave it as an improper fraction. Bring down that plus 3/5. Now we're going to add 8/5 plus 3/5 is going to equal 11/5. And we can't leave this as an improper fraction, so let's convert it back to a mixed number. How many times does 5 go into 11? 5 goes into 11 twice, with 1/5 left over. So I would say 11 divided by 5. 5 goes into 11 twice. I subtract. I write that remainder. 1 as my numerator. The number I was dividing by 5 is my denominator.